Not
Hopefully it'll start to click. I know it's a lot at you at first. We had left off on this yesterday, okay? So we left off and we were talking about characteristics of ionic and covalent bonds, and we talked about solubility. And we stopped here, we was talking about just going through the characteristics of ionic bonds. We stopped here talking about solubility. And in terms of solubility, when we're talking about this, we're talking about in water. And we said that ionic bonds love to do it. So whenever we said that, we went through, we did an electron dot diagram. We showed how the electron goes from sodium over to chlorine. And then the sodium becomes a cation, and the chlorine becomes an anion. And then what happens is the actual salt that we get is this crystalline structure to where they just line up, sodium, chlorine, sodium, chlorine, sodium, chlorine. And they just keep going. So the sodiums are surrounded by negatively charged chlorines. So you can see here, there's sodium, chlorine, 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 chlorine. Because that positive and the negative charges are attracted to each other. So they're attracted and they literally build up this crystalline structure. Now why is it that ionic bonds like this are so soluble in water? And to do that, we had to look at the water molecule. So we drew out this water molecule. Very nice. In this we talked about how that is a polar molecule. We talked about how we found the difference of electronegativity. And the hydrogen is partially positive and the oxygen is partially negative. That's where we left off. To pick up there, why is it that ionic bonds like this will dissolve within water and they're soluble is because of that partial positive and that partial negative. It's the same thing that's going on in here, just water comes in and breaks everything up. So like what will happen is at this positive, at the sodium, there'll be an oxygen. You come over here at this chlorine, there'll be some hydrogens. Why are the hydrogens lining up with the chlorines and why is the oxygens lining up with the sodiums?
It is Friday morning.
Did that take like way longer than it had to be?
Boys basketball team, please come to the cafeteria.
Okay, so in this, why is the oxygens lining up on the sodiums and the hydrogens lining up on the chlorines?
Because of the S's. The S negative and the S positive.
What's that stand for?
I don't know.
It's lowercase delta. It's partial negative, partial. What do opposites do?
Attract.
They attract. So oxygen is partially negative. So which one of the ions will it line up with?
The positive.
The positive. Where it's partially negative, it's going to line up with partially positive. The same thing for the chlorines and the hydrogens. The hydrogens are partially positive. Going back to that whole relationship thing we was talking about yesterday. This is kind of the whole thing going on. You got like oxygen here, is sodium's like BFF. And it's like, girl, you need to break up with him. He is trash. He don't treat you right. Girl. We need to slice his tires. We need to like cut up his seeds and just tear up his car paint. And hydrogen's over here, and hydrogen, there's like fine looking honeys that's walking down the hallway, and chlorine's like, hey, how you doing? And it's just a big mess, which this leads to a big mess. Because if you put salt in water, you get salt water. And if anybody's ever had salt water, it's not very enjoyable. It's just a big, awful, horrible mess. This is why ionic bonds are soluble in water. Any questions?
Why is this important?
It's the foundation of everything. You got to know, if you mix A and B together, what's going to happen. You got to know if there's an ionic bond or a covalent bond.
I feel like you're just telling me I should go mess with my vehicle.
No, that is not what I said. So in this, I'm like, you can use these characteristics. I can give you pieces of information on a substance, and you can determine whether there are ionic bonds in it or covalent bonds in it. Which you can't determine that yet because we haven't filled out the chart. We're getting there. We're getting there. So no questions besides why is this important? Y'all like drink half a bottle of NyQuil this morning or something before you came? Or
We need to all go to Goodson's and get a Monster or something.
get one of the big ones. It's been a long day.
And we can test to see if it's made of ionic or covalent bonds.
I love how y'all just come up with anything, a fish, anything. Yeah, let's go fishing. We will check and test the velocity of the fish that is coming towards us and out of the water. All right. Let's look at texture. So texture, think about it before. Like right now it's really popular with, we're coming out of the season, but with salt and everything going down on roads. You know what? That's a perfect example. To answer your question, I'm only going to like an eighth through my coffee. Give me a moment. That's why this is important, because it's a perfect concept. What happens in winter? We get snow. Snow gets on roads. What's it make on road? Ice. What is ice?
Cold.
Slippery.
Cold, slippery. But it is
Water.
water. So, if we take an ionic compound and put on it, guess what happens?
It dissolves.
It lowers the freezing point because of this natural attraction. So there is no longer slippery, wet roads. This is why it's important. Back to the texture. So think about that salt we're throwing out on that road. Some of you have probably held it in your hands before and you felt it. It's kind of like hard, it's brittle, it's like a crystalline, brittle structure. So that's what you're looking at texture-wise. Hard, brittle. Now here's my personal favorite one. The last one. Conductivity. There's been a lie that has been told to you your whole life. And I came to school today just to correct this lie. When people talk to you about water and electricity, what did they tell you?
Water conducts electricity.
That is a lie.
Like,
I know I'm freaking you all out right now, right?
my whole life has been a lie.
Water does not conduct electricity. It does not. You can take a thing of complete distilled water, send an electrical charge through it, it will not conduct it. Now, if I got tap water, it absolutely will conduct the daylights out of electricity. But it's not the water that's conducting the electricity, it's the ions that are within the water. And where do we get ions from? Ionic bonds. So in this, ionic bonds love to conduct electricity. Now they have to be dissolved in water. That's how we test it. That's why I added once dissolved in water. H2O is water, by the way, if you didn't know that. Just throwing that little tidbit of information out there. Letting you know. So anyway, do they conduct electricity? Yes. They love it. Those are the characteristics for ionic bonds. So their melting points are extremely high. I didn't add the boiling point here, but if the melting point's high, the boiling point's high. Flammable. Ionic bonds really not. I know before anybody gets sarcastic and says, well, everything will burn, you just gotta get hot enough. Yeah, but you're not gonna burn salt very easily. It's gonna take some work. Solubility. Ionic bonds love to dissolve in water. Why?
Opposites attract.
Opposites attract. You have water, which is a polar molecule. The polar molecule is attracted to the ions, the cation and the anions within the ionic compound. Texture, it's hard and brittle. You can throw crystalline structure in there if you want. I'm really not that concerned about it. Conductivity, they love to conduct electricity. See? God, just like, duh.
So will lake water conduct electricity?
Lake water, if there's ions.
How do you know if it's ions?
We have to test it.
If it
How
conducts
do you test
electricity.
Now, I do want to make sure, and I am recording, so I am saying this. I did not tell you that it was safe for you to go swimming in the middle of a thunderstorm because electricity, the water does not conduct electricity. Guess what's inside of you? Ions. So if we stick us inside of water, guess what is now in water? Ions. So guess what's going to conduct the electricity?
Us.
You and me, okay? That's no bueno. It's no good. I'm not telling you to go out and start messing around with electricity and water. Mr. Hall did not say that. I said distilled deionized water will not conduct electricity.
So what I'm hearing is if we got a swimming pool just filled with distilled water, would it be safe to live?
What's your framing made of?
Could you go swimming during a thunderstorm?
No!
Full of
You are made of ions. Ions are in you. You conduct electricity, you get shocked.
So now we just gotta take the ions out of ourselves.
Yeah, how do you do that?
Oh boy, you're gonna die.
Oh.
That's the reason all that's in there. All right. So let's now move to covalence. Now these are general characteristics for covalence. In this, you cannot use these characteristics to narrow it down between nonpolar or polar. How do you narrow it down between nonpolar and polar? I wait for response.
Math. That's all I got.
So Thomas is the only one that did not take the NyQuil, and Thomas is just giving me random guesses. Thank you all. Thank you all so much. No more NyQuil anymore. What did we do here?
Subtract
What?
the electronegativity.
The difference in electronegativity. Bada boom, bada boom. Y'all doing wonderful today. I tell you what. Now wake up. So in this, we find the difference in electronegativity. That's how you tell the difference between nonpolar and polar. Got it?
Got it.
Got it.
Got it. Okay. So let's talk about characteristics of covalence. So melting points. Melting points for covalence, they low. Low. Very low. Perfect example. Water. Room temperature. What is it? What phase?
Water.
Oh my gosh.
Liquid.
Liquid. Thank you.
Oh, okay.
Thank you. Okay? Think about rubbing alcohol. It's liquid. Room temperature. That's what you're looking at here. I mean, room temperature, you can melt these things. They're already at a liquid, or they can be gas. Perfect example. My gas. That was that. I did not fart. Thank God. A little bit of liveliness in the room. I feel like your second period teachers owe me like a bunch. I feel like I get y'all woke up and get you rolling and going in the morning.
And then Ames depresses us.
Y'all got Ames second?
Yeah.
I'm going to tell Ames he owes you one then. All right, so let's talk about flammable. I will give you a hint.
Yes.
Yes! Burn, baby, burn!
Can you blow something
That would be like
up? Is that like the school building or something?
Pretty sure I'll go to prison for that. For the rest of my life.
Not if it's an accident.
If you just leave the thing on and something happens.
you don't get caught.
Okay, yeah, but you have to find like, oh, this is a really good thing. You got me rolling. Like, you got me really excited for us to get to stoichiometry now because you have to find like the perfect ratio, because if you get too much on one side, then it won't ignite. If you get too much on the other side, then there'll be a fire that just rolls out, but there won't be like an actual like explosion like a bomb. There has to be the perfect mark of both the fuel and of the oxygen. That's how we get the explosion.
The fuel.
This is the fuel. Oxygen's in the air. It has to be a perfect ratio for bomb.
The burn?
No,
Explode.
for explosion.
Oh, I thought we were just talking about burning.
Oh no, it'll burn just like as long as there's 21% oxygen in the air. Okay.
My car being broken into.
We should go
The
check on
car.
So flammable, absolutely. These guys like to burn. Okay, they will roll. Are they soluble in water?
it. No.
No. As a general consistent. When you look at it,
It's gonna fall on there.
I'm going to say not really.
Oh, yeah.
Don't get
There's
it
a
back
bug.
here.
What is y'all problem?
There's a bug.
It's a stink bug.
Where?
It's flapping around.
Don't kill it.
Get it.
Won't kill anybody. Murderous thing.
Someone shut the
He
door.
wanted bonus points.
Okay.
You're just trying to get friends.
So they're not really soluble. Now, like, there's parts that you can technically say are, but in a general rule, they're not. This is kind of like water and oil. Like, it doesn't mix. But then it's like, kind of like, you know, making sweet tea. How many of y'all in here made sweet tea before? What you put in the tea to make it sweet?
Sugar.
Guess what sugar is?
Soluble?
A covalent bond.
Oh.
And it will dissolve within the sugar. Now, there's a reason behind that between the polar interactions happening there. But as a general rule, they really will not dissolve. Okay? So texture. We're speaking of texture. This is probably my favorite one. Remember me telling y'all about the teacher that I did my clinical twos with? And she got on to me saying that I was giving emotions
Yes.
and making them like people. Okay, I got in trouble for this one too. And I thought when I did this one, texture of covalent bonds. There's only one word I can think of. Squishy.
I knew you.
Why'd you get in trouble?
Because she said that's not a real word.
It said it is though.
I said covalent bonds are squishy. Now, please, for the love of God, do not go to college and go, my high school chemistry teacher said covalent bonds are squishy.
Why not?
Because some professor's going to look at you and say, you a dumb hick. And you just do what I did. You just smile and say, and then take the test and get an A. I actually had a professor one time that she literally caught me outside of class. Like, we were getting ready to walk in her class, and she looked at me and she goes, how did you do it? I go, how did I do what? It's like the test. I was like, well, with a paper and pencil. You gave me the paper. I just used the pencil. She said, no. How'd you do it? I'm talking, this is a really hard professor, like, really hard professor. And she looks and goes, "You got a B. How did you get a B on my test?" I went, I studied? It's kind of like, what are you, like, I'm confused here. So she's like, "Yeah, but it's just like, I just don't get it. I don't know how you did it." It's like, "Well, I studied." Ain't that what you're supposed to do? So, end of the year, I take the final. She tells me to stay in the class. Afterwards, I turn it in. She looks at me and says, "I need to talk with you." And I'm like, "Okay, what's up?" And she looks at me and she goes, "I gotta apologize to you." I was like, "For what?" And I mean, me and this woman, we were like really tight. Like, I just thought it was funny that we ended up really liking each other. And she's a real cool professor. She's kind of like a grandma that you were going to wait to bring you cookies, but instead she brought you a test. That's weird. Well, she looked at me and said, "I have to apologize to you and say that I'm sorry. I thought you were nothing but a dumb, stupid, hick hillbilly, redneck from southern West Virginia that would never amount to nothing." And I was like, so I just looked at her and I went, "Well, that's all right. I forgive you." Hick accent and all. And she got tears coming down her face and everything. She hugs me. And I hug her, and I'm like, "It's okay. It's all right. I get this all the time. People around here think I talk funny, and they think I'm dumb because of it." So she looked at me, and it was like from that point, she became my biggest encourager. Like, she would push me farther and farther and say, "You can do anything you want to." So I encourage you, if you talk with a hick accent like me, or you go to college, prove everybody wrong. When they look at you and say, "You dumb, stupid hillbilly," prove them wrong. I did do that to an English professor one time, and that didn't end well, because then, like, he thought I was a dumb, stupid hillbilly that knew nothing, so then he never called on me in class. Then I gave a presentation, and he tried to, like, give me questions that was going to, like, destroy my life, and I came back and answered them perfectly, and then from that point on, he realized I wasn't a dumb, stupid hillbilly, so he called on me all the time. So don't do it in the English class. Go under the radar.
You're like bare minimum.
Get what you got to get the grade and get through. Now the other classes, like you go to chemistry, ball out. Capiche? Very nice. Conductivity. Are they conductive once dissolved in water? Kind of a combination here. Go back to solubility. Do they dissolve in water?
Not really.
So will they conduct in water?
Not really.
No, not really. This one is a general no, really. And this is a perfect example. It's like in this lab, whenever this is when we would make it to the point we'd actually like start dealing with some real chemicals in the class. You would do this lab, and I would give you sugar to confuse you, because sugar would dissolve within water, but
If
it's
you
not
signed
supposed
up
to.
to attend tonight or tomorrow night's game and you haven't paid for your ticket yet, your pre